Okay, so we're going to look at the Lesson 3 independent practice activity. Okay, number 1. Dusty's earnings vary directly with the number of papers he delivers. The relationship is shown in the graph below. Determine the amount that Dusty earns for each paper. So we need to know the unit rate, okay, which is going to be how much money per paper, or how much money, if I were to do a table, how much money for one paper. Okay, and if we look at our axis, the number of newspapers is X, and the amount of money is Y. So my table's a little bit backwards. If that bothers you, we can rewrite it. And I can say, okay, well, my X is money, my Y is papers, and I want to know how much for one paper. So to help us figure that out, let's take a look at our graph, and they have some points that they gave us here. And we can use those points to create a table. So if we have 2 newspapers, it's $1. If he sells 4 newspapers, it's $2. And what we can do is we can take that pattern and we can use the pattern to help us fill out the table. So if I look here, 4 divided by 2 is 2. 2 divided by 2 is 1. Okay? 1 less, okay, or excuse me, divided by 2. 2 divided by 2 is $1. $1 divided by 2 is 50 cents. So if you use the table, you can get our answer of 50 cents. If you would like to use the graph, you could look over at the graph and say, okay, well, if he sells 1 paper, where's this point? Well, between 0 and 1 is 0.5, 50 cents. So you could either use the table to get, or use the graph to get your answer, or take the pattern and use a table. But our unit rate is going to be 50 cents per paper. Number 2, the Thompson family is buying a car that can travel 70 miles on 2 gallons of gas. Assume that the distance traveled in miles, y, varies directly with the amount of gas used, x. So miles is y, gas is x. When it says varies directly, that means that there's a pattern that you can trust and follow. Okay, so this can be represented by y equals 35x. So this is our equation. Y equals 35x. Graph the equation on the coordinate plane. How many miles does the car get per gallon? So you have a couple options here. I could take this equation and I could make a table. And I could pick an x and get y's. So if I pick my x, I would say 35 times 0 equals 0. 35 times 1 equals 35. So all I'm doing is doing like a function table where I take the x and I substitute it into the equation and get a y. Okay, and so my points would be 0, 0, 135, 270, and if you notice, there's a pattern here that I can just continue, and I have a line. That's it. Okay? Then it says, how many miles does the car get per gallon? So per gallon is 1 gallon. So for that, I could either look at the graph and say, okay, per gallon is right here. And this point is at 35 on my graph, which would mean 35 miles per gallon. Or I could have looked at my table and said, well, x is gallons. If x is 1, y is 35. 35 miles per gallon. Number 3, Tom was comparing computer repair companies. The cost y for computer access for x hours is shown in the graph. Okay, so this is the company Computer Access. The cost for computers R Us can be represented by the equation 23.5x. Which company's price is lower? So here's the deal, what's happening. They're telling you Computer Access, their price information is in the graph, and Computers R Us information is in an equation. Now, it's very difficult to compare things when one's an equation and one's a graph. So my suggestion is either have 2 equations that you can compare or 2 graphs that you can compare. Now, you don't quite know how to write the equation, but what we do know is we do know just from discussions and from putting 2 and 2 together, this 23.5 is our unit rate, or it's basically if our cost is Y and X is hours, it's our price per hour. So for Computers R Us, it's $23.5 per hour. Because we know that from our graph, or from our equation. That M, the 23.5, is our pattern. It's our unit rate. It's our price per hour. So if I look at my graph, I can't really tell how much it is for 1 hour because this graph is it's in a weird spot. But what I can do is I can look at this and say, okay, well, where do I do know there's a point? Well, I know there's 0, 0 here. And I do know if I plot this point right here, at 2 hours, it's going to cost $50. So if 2 hours cost $50, 1 hour would be how much? $25. We know that because we know there's a pattern. Because it created a straight line, we know there's a pattern that we can trust and follow. So we know that if 2 hours cost $50, 1 hour must be $25. So for computer access, it's $25 per hour. So which company has a lower repair price? Okay, it is Computers R Us. Okay, so Computers R Us is the cheaper price. Number 4. So for number 4, the weight of an object on Mars varies directly with the weight on Earth. So again, we have a pattern. An object that weighs 50 pounds on Mars, so let me just create a little table here so I can keep track of my information. So if it weighs 50 pounds on Mars, it's going to weigh 150 pounds on Earth. If an object weighs 120 pounds on Earth, how much will it weigh on Mars? Now, because it told us it varies directly, that means there's a pattern that we can follow. The other thing is all of our equations are in the form y equals mx. So our patterns are multiplication or division patterns. Okay, the reason we know that is because our m is our unit rate. This is our pattern. And our pattern is being multiplied by x. mx means m times x. So because our pattern is being multiplied by x, we have a number that the pattern is going to be a multiplication problem or division. Okay. So what I look for here is, I could say, well, 150 divided by 3 gets me 50. So 120 divided by 3 would be what? It would be 40. That's it. 40 pounds. It's that easy. Okay. We could have also graphed it. You could have said, you could have gone by, the 20s, and you could have graphed the 150 and the 50. That would take a long time. I'm not going to do it. A lot of times if you just create a table or just write out the important information, you can kind of see the common thread here is that we're finding a pattern. We find a unit rate. I could have said, well, 1 pound on Mars equals 30 pounds on Earth or whatever. And then I could have applied that as well. So there are a lot of different options that you had on this. I think the easiest way was to make a table and just look at the pattern and follow the pattern. All right, 5 and 6, there's no word problem. There's just a table. Look for a pattern. It says determine whether each linear function is a direct variation. So what they want to know here is there a consistent pattern or unit rate? So can you come up with a unit rate? So if I look here, 5 times 4, 20. 6 times 4, 24. 7 times 4, 28. 8 times 4, 32. Yes. Okay. The constant variation now our constant variation is, that's the same as our slope, which is how the y changes over how the x changes. So we actually want to retake a look at this. And when you write your constant variation, it's the ratio that we have from the y to the x. So we want from y to x. So that would be the change in the y over the change in the x. That's what they're talking about when they want the constant variation. So what's happening is we would have 4 over 1. So if we take a look, a couple things here. 4 over 1, if basically what's happening is 5 times 4 is 20. It's true. But if I also take a look at my x's and my y's, do you see how the difference between my y's is 4 and the difference between my x's are 1? 4 over 1. Okay? So it's another way to look at that. All right, so the next one, if we take a look here, 5 times 2 is 10. 6 does not work. So no. Okay? Now be careful. Something very important. From my y's here, I do have consistent patterns. It does increase by, my x is increased by 1 and my y is increased by 1. So there is a straight line happening here. However, it's not what we're looking for. We are first looking to see, is there a pattern that gets from the x's to the y's? Like, could you create an equation? Is there a consistent pattern from x's to y's? If there is, then your answer is yes. And from that point, you look at how the x's and the y's change. But for right now, there is no consistent pattern, so there's not a direct variation. Okay, let's look at number 7. The numbers of centimeters varies directly with the number of inches. Find the measure of an object in centimeters if it's 50 inches long. Okay, so if we take a look here, we have to figure out how did we get from 15.24 to 6? How do we get from 22.86 to 9? Okay, so if I make a ratio, it says it directly varies, so that means that all these ratios are equal. Okay, so all these are going to equal each other. If I can figure out what my numerator is when my denominator is 1, this will give me my unit rate. From a unit rate, then I can figure out, well, if it's 50 inches long, how many inches? Or excuse me, 50, hold on. Let me back up. Okay, this is my centimeters. This is my inches. Okay, just so I'm clear when I'm writing everything out, I'm not doing anything, not making any mistakes. So I want 50 inches long. So if I can find my unit rate, I can figure out 50. Okay, so to help me find my unit rate, what I can do is I can say, well, I need this number to become a 1. So if I divide 9 by 9, it becomes 1. So just simplifying fraction process, if I divide 22.86 by 9, I will get 2.54. Now, because it says it directly varies directly, if I were to say 6 divided by 6, that also equals 1. So 15.24 divided by 6 should equal 2.54, and if you type it into a calculator, it does. So what that tells us is that for every 1 inch, I have 2.54 centimeters. So, in that case, if I need to figure out 50, how do I get from 1 to 50? Well, I times by 50. So then I'm going to take 2.54 and I'm going to times by 50. So it's just fraction work. It's simplifying fractions and it's dividing each number to simplify the fraction, or multiplying each number to it. Everything's equivalent. We're just changing the value of the numerator and the denominator, but ultimately the ratios are all the same. So what I end up with is 127, which means for 50 inches long, it's 127 centimeters. Okay, so again, it's ratio work, it's fraction work. It's find a unit rate and use that unit rate to figure out a different rate. Okay, number 8, you have a couple different options on how to get through number 8. Basically, what it's telling us here is if I have a table of x's and y's, let me adjust that for a second. I need to find the pattern. So if x is 9, y is negative 12. If x is negative 4, I do not know what y is. Okay, since it says it varies directly, that means there's going to be some sort of pattern. Now this pattern is going to be y equals mx. Okay, that will help us find our pattern. I know the y and I know the x. So let's take a little sidestep for a second. If I know my y is negative 12 and I know my x is 9, all I have to do is figure out the m. This is an easy equation to solve. My m is negative 12 ninths, which simplifies to negative 4 thirds. So what we have here is my function formula is going to be y equals negative 4 thirds x. What does that mean? That means that now for my mystery number, I can say y equals negative 4 thirds, substitute this x in for the x, times negative 4, create a fraction, and I end up with 16 over 3. That's it. Use this y equals mx to figure out your pattern of that function table. Okay, now for number 9. 9 actually does have a more simple way to figure out your answer, but I do want to complete it the way we did on the last one, just so that there's consistency. So y equals something x. All right, so if x is 10, y is 8. If x is 20, what's y? Now just by looking here for a second, do you see how my x is doubled? Well, because it directly varies, if my x is doubled, then that means my y is going to double, so my y would end up being 16. Okay, now let's say it wasn't that simple, like number 8. Number 8's not that simple. You have to have a process for when you can't do it in your head. Okay, and that process is y equals mx in this case. So I have a y, which is 8, and I have an x, which is 10. I just have to figure out the m. Solve the equation, and I get m equals, if I divide each by 2, I get 4/5. Okay, so all I have to do in this equation is make it y equals 4/5 x. So I say my y I don't know, 4/5 times my x is 20. Okay, I need to make the 20 a fraction, and what I end up getting is 80 over 4, which simplifies to 16. Now I want you to try 10 on your own. I'm going to complete it, so hit pause, try 10, and in just a second hit play and you will see the answer. Okay, so your answer for 10 was negative 28 thirds. I will tell you this was a little trickier. There's a couple things that I want you to take note of. I filled out my table, you'll see it in blue, and when I went to the equation, look over here in the orange, when I solved, I ended up getting m equals 3/7. Now here's the tricky part though. If you look at our information, they gave us the y this time. So I knew my y was negative 4. Okay, so I'm rewriting this in orange. So I knew my y was negative 4, so when I did my equation, I had to say negative 4 equals 3/7 x. Okay, let me erase my work here for a second. So I said negative 4 because that's our y, that's what we know, equals 3/7 x. Now, if you forgot about how to solve equations, whenever you have a coefficient that's a fraction, if I multiply by the reciprocal, see how my 7's will cancel and my 3's will cancel and I'm left with an x? So I multiply both sides by 7/3. Okay, make 4 over 1 a fraction, or negative 4 over 1 a fraction. When I multiply, I get negative 28 over 3. Okay, number 11. Write 3 ordered pairs for a direct variation relationship where y equals 12 and x equals 16. Okay, so again, same type of thing as 8, 9, and 10. If I have y equals mx, I have y is 12, m I don't know, x is 16. Let's solve that equation so we can figure out our pattern. If we find the m, we can find our pattern. So if I divide each of those by 4, I get 3/4 is m. So my equation for my direct variation is y equals 3/4 x. So now I can pick whatever I want. I can pick x is 0. Okay. Y equals 3/4 times 0. 0. X is 1. Y equals 3/4 times 1. I get 3/4. Okay, so I have an ordered pair of 0, 0. I have an ordered pair of 1 and 3/4. Now you come up with the last ordered pair based on the same type of work. Okay, number 12. The amount of stain needed to cover a wood surface is directly proportional to the area of the surface. So again, that means y equals mx is going to be our equation. Okay, so the minute you see directly proportional or varies directly, we know it's going to be y equals mx. Let me make that a little more clear. Okay. If 3 pints are required to cover a square deck with a side of 7 feet, how many pints are needed to paint a square deck with a side of 10 feet 6 inches? Okay, so pints and inches. Okay, so our pints are 3 inches. Oops, not inches, it's feet. Now, I don't know which is the x and which is the y. Honestly, we will get the same answer either way. So my focus is now to find out 10 feet 6 inches is 10.5 feet. So I need to know how many pints for 10.5 feet. Okay, so I'm just going to call the pints x and the feet y, just because. So with my equation, I'm going to say 7 equals m times 3. Divide each side by 3 to solve my equation, and I get a reminder that cancels. M equals 7/3. So if I have my y, I have 10.5 equals 7/3 times x. All right. Solve my equation. To solve it, I'm going to multiply each side by 3/7. That will cancel my 3's, and that will cancel my 7's. Okay, gets a little bit tricky here. Just use your calculator. 3 times 10.5 over 7. Okay, that gets me 31.5 over 7, which equals 4.5. So if I have 10.5 feet, I'm going to have 4.5 pints. Okay, and our last one, 13, describe 2 real-world quantities that have a proportional relationship. Explain how you could change the situation to make the relationship non-proportional. This one's a tough one. Okay, so basically, with real-life situations, what we've noticed with each thing is that they all start at 0, 0. And here's what I mean by that. Okay, so if you've noticed with all of our graphs, every single graph goes through the origin. The origin is 0, 0. So your real life situation needs to have a 0, 0 starting point. If you take a look at number 2, so look at independent practice number 2. If you have 0 gallons of gas, that means you go 0 miles. Okay, so if you've had 0 gallons of gas, you go 0 miles. Or if you go 0 miles, that means you have 0 miles of gas, or 0 gallons of gas. Okay, another example, if you were to look at the newspapers. So number 1, take a look at number 1. If he delivers 0 newspapers, how much money will he make? $0. Okay, so a good place to start is think of a situation where you can start at 0, 0. Like if I babysit, I get paid for 3 hours of work, I get paid $12. For 0 hours of work, how much am I going to get paid? $0. So I could say for babysitting, I make $12 for 3 hours. And then you have to figure out how much for 1 hour. So that would be the type of situation that I want you to come up with. And you would just go ahead and do one real world situation. And then I want you to think about how could you change it so that it doesn't start at 0, 0. What does that mean? What does that look like? So do your best on number 13. And that's it.